In this video, we will learn how to apply Cauchy integral formula. Cauchy integral formula is integral over C f of z by z minus a dz is equal to 2 pi I f of a if a lies inside C, 0 if a lies outside C. So here the main thing we have to identify whether the given integral is of this form f of z by z minus a. And then we have to find a value. If a lies inside the curve, given curve C, then we apply the first equation 2 pi I f of a. If a lies outside C, then we get the answer is a very simple thing, that is 0. Okay, important session. Let's go to the problem session. So note down this before going to the problems. Mod z minus a is equal to r denotes a circle. Okay, it denotes a circle with center A and radius r. So whenever you come across a equation which is of this form, that is modulus z minus a is equal to r, you should identify it as a circle. Okay, you should identify it as a circle where a denotes the center and r denotes the radius. Okay, now the first problem, evaluate integral over c z plus 1 by z minus 4 dz where c is modulus of z is equal to 2. So first we should verify whether the given integral is of this form, that is Cauchy integral form, f of z by z minus a form. So here f of z by z minus a. So integral over c, you compare with this. Numerator is f of z, right? Here numerator is f of z, denominator you have z minus a. So what about this question? Numerator is f of z, denominator is z minus a form. So we can write here, okay, this is its solution. So let me write solution. Here f of z is the numerator, that is z plus 1. So always you should identify f of z is the numerator and denominator z minus a. Now a z minus the term here, it is a term. You can comparing with the denominator z minus a. What is a? A is 4. So numerator is f of z, denominator you have a term. So you can write the numerator f of z is z plus 1 and a is equal to 4. Okay, here a is equal to 4. Now we have to verify this a, whether it lies inside or outside the given curve C. What is the given curve C here? Given curve C is modulus z is equal to 2. So we learned mod z minus a is equal to r denotes a circle. So here modulus z is equal to 2 is the given curve. Okay, C is mod z equal to so this can be rewritten as mod z minus 0 is equal to 2. And now what about this center? It is a circle, right? Mod z minus a is equal to r denotes a circle. So it's a circle. This is a circle with center is equal to 0 and radius is equal to 2. So it is something center 0 and radius 2. So this circle modulus is equal to 2 is a circle with center 0 and radius 2. So you can draw a circle like this, and this center it is 0, radius 2. So what about this end point? This point will be 2 and this point will be minus 2 because radius is 2, right? Radius 2 means what will be the length here? It is 1, 2. So this end point will be 2. This is minus 1, minus 2. So this end point will be minus 2. So now let us verify what about the a value here. Here a is equal to 4. So 1, 2, here you have 3 and here you have 4. 4 is a point somewhere here. Okay. Now what happens 4, whether it lies inside or outside? It lies outside C. Okay. It lies outside the curve C. So what is the answer by using Cauchy integral theorem? A is equal to 4 lies outside the curve. Okay, outside the curve mod z is equal to 4, mod z equal to 2. Okay, it lies outside the curve, CURV, outside the curve, mod z equal to 2. So we know when A lies outside, it is not, if it is inside, it will be some point here, right? But it lies outside, 4 is outside the curve, and the solution is, when A lies outside, what will be the integral value? Integral value 0. So simple. Here the answer is, therefore, by Cauchy integral formula, you can write the solution. So let me write here. By Cauchy integral formula, integral over C z plus 1 by z minus 1 dz is equal to 0. So our answer is 0. So you can write the answer like this. By Cauchy integral formula, integral over C z plus 1 by z minus 1 dz is equal to 0 is the solution. So it's very simple. Next question, evaluate integral over C z square plus 2 by z minus 3 dz, where C is modulus of z is equal to 2. So here, solution here, what is f of z? Comparing with this, f of z is numerator and you have a in the denominator. So we'll write the f of z term. Here f of z is equal to z square plus 2, and a value is this particular value, z minus a. A is 3. Okay, now a is 3, and let us verify whether it lies inside or outside. We need to draw the circle. So circle here, when you draw the circle, we have to identify z, modulus of z is equal to 2 is a circle with center 0 and radius 2, right? So we learned mod 2 is equal to 2. It denotes a circle whose center is 0 and radius is 2. So if you draw a circle here, this end point, since radius is 2, this point will be 2 and this point will be minus 2. And what about 3? 3, where it lies? 2 is here, then this particular point is 3. It lies outside the curve. Okay, this is C. Mod z equal to 2 is the circle. 3 lies outside. So it lies, 3 lies outside the curve. Mod z is equal to 2. Therefore, by Cauchy integral formula, what's the value? If a lies outside, integral value is equal to 0. So it's so simple. Therefore, integral over C z square plus 2 by z minus 3 dz is equal to 0 is the solution here. Next question, evaluate integral over C 2z by z minus 1 dz where C is modulus of z is equal to 2. Here, okay, solution, here f of z is the numerator, as you know. We have to compare it with the general integral formula. F of z is the numerator and we can take z from the denominator. So we write f of z as 2z and a is nothing but z minus a. What is a? A is 1 minus z minus a. So a value is 1. Now let us draw this circle and we will identify whether it lies inside or outside. So we have a circle modulus z is equal to 2 is a circle with, okay, circle with center 0 and center is 0 and radius is equal to 2. So you can draw a circle with center 0 and radius 2. Radius 2, end points 2 and minus 2 because our radius is 2, center point is 0. Now what about this 1? 1 is a point, whether it lies inside or outside the circle. It's very simple to identify. Point 1 is here, right? 1 is here. 1 lies inside the circle. Inside the curve mod z is equal to 2. So when it lies inside, what is the equation? If A lies inside, our answer is 2 pi I f of A. So we'll apply it here by Cauchy formula. Let me write that here by Cauchy. Okay, by Cauchy integral formula, integral over C f of z dz. F of z by z minus A dz is 2 pi I f of A. A lies inside C. A lies inside C. So integral over C, f of z by z minus A, that is our question. Okay, f of z is 2z, z minus A is z minus 1. We can take the entire question. Okay, this is of the form f of z by z minus A, and this is equal to 2 pi I f of A. Now how to find f of A? We know f of z is equal to, f of z is nothing but the numerator here, right? F of z is the numerator. We have it here. F of z is 2z. So f of z is 2z. Then what will be f of A? F of A, that is 2 pi I f of, what is A value? A value is 1, right? So I write, instead of A, I can write 1 here. A value is 1. F of 1. F of 1 is equal to, f of z is 2z. That is the numerator. F of 1 is, then replace z by 2. Okay, you can replace z by 1. 2 into, now z is 1. So 2 into 1, that is 2. So I write 2 pi I into 2. What is f of 1? F of 1 is 2. So instead of this f of 1, I write 2. 2 2s are 4 pi I is the answer to this question. Okay. So whenever you come across a question where f of z and is given, f of z can be taken, and a value is very important thing. A value, it lies inside. Okay, it lies inside the curve. If it lies inside the curve, by Cauchy integral formula, 2 pi I f of A is the answer if A lies inside. So now how to find this f of A? How to find this f of A? F of A you can find using the f of z function. Okay, f of z is the numerator, that is 2z. Now f of A is, A value is 1. Okay, A value is 1 here. So now we write f of 1 is 2 into, instead of z we take 1. So we get 2. Now replace it. Replace f of 1 by 2. You have to replace this whole function. Okay, you have to replace this whole function f of 1 by 2. So that you get 2 2s are 4 pi I is the solution.